today we're doing electromagnetic induction, which has to do with motors and generators. So before we start answering questions, I feel like it is important to understand the difference between the two and how it actually works, so that when you're answering the questions, you know how to actually answer and you know what the examiner is looking for. Because in this type of question, the examiner actually wants to know whether you understand the conversion between the two. Is it electrical or mechanical? They also want to know whether you understand the different compartments that actually make this what it is. So for an example, if we're talking about generators, so if we're talking about a generator, I want you guys to think about actually doing work. When the power goes off and it's dark and we've got no lights and we want to actually put the lights on, we need a generator. But you don't just plug in a generator and everything starts working. You have to put in some mechanical work. So you have to pull the generator and then it goes drrr, 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 and then all of a sudden drrr, and then it starts working, right? So you first do some mechanical work and then you can have electricity. So a generator is mechanical energy to electrical energy. Whereas a motor, if it's really hot and you're busy fanning for some air and you're really sweating, what do? You plug a fan. So you plug it in, it needs electricity. And what does it do? It does all the mechanical energy for you. So you plug in your flame, and then as the fan is rotating, that's where you get the air and it does all the mechanical energy for you. So a motor is then electrical energy to mechanical energy. The examiner wants to know whether you know the difference between the two. And then there's a bit of a trick. Then you also get what we say a DC generator or motor, and then you have an AC motor or generator. So now the difference between the two is that the one has got split rings, right, which is the DC for direct current, and then the one has got slip rings, which is alternating current, which we also call AC. So when you are answering a question, my advice to you, sit down, look at it, scrutinize it, and then you'll be able to know what to do. Another important thing when you're doing electromagnetic induction is that you need to use your hands in order to actually find the correct answer. So sometimes they might ask you which direction is the current flowing or which side is the magnetic field and so forth. So you have to use Faraday's rules and laws in order to, so you must use your hands. Remember, this is the force, this is the magnetic field, and this is then the direction of your current. Very, very important. In the exam, don't be scared, use your fingers. It's actually very easy marks. So the first question that I have today, it's from Unathi Lubisi, and Unathi has given us this question. It's question 10, and it's a 2018 paper. So Unathi's question says, in the simplified AC generator, already I can see AC. Let me use another color. AC means alternating current. So what happens is with alternating current is that the current will alternate. The current will alternate at every turn, at every half turn. So the current will move in this direction and then in this direction and then in this direction and then in this direction. Whereas when we talk about direct current, the current then remains the same throughout. So already I'm scrutinizing that one. Let me use a different color. Let's use blue. So we have alternating current and it is a generator. Already I know that a generator will then move mechanical energy into electrical energy. And this is what's happening here. I've got north and south, which is my magnetic field. And always remember, now the examiners love doing this. When we talk about a magnetic field, it will always move north to south. So now what the examiners do, and you shouldn't cram this, they might actually move the magnets the other way around. So even though they move them the other way around, you must always make sure that it moves from the north to the south. I always say people leave North America to come to South Africa. So always remember it like that. It'll move in that direction. And then I've got a coil here, or what we call an ammeter. Then I've got a Y here and I've got X, and there's a meaning. Usually if they give you alphabets like that, you have to give the direction of the current. And remember, if they ask you in which direction the current is going, do not say from top to bottom or from bottom to top. You have to use the alphabets that you're given. So you're going to say from X to Y or Y to X or X to Y. So that's my coil. Then I've got two rings here. So these are slip rings, and that is why I've got an AC generator there. Then I've got my brushes there, which are usually carbon. So I've already scrutinized it. So now, as I'm answering, I already know what I'm working with in my head. So the first question says, in which direction does the induced current, remember when you do electricity, we also speak about current, does the induced current flow in the coil? Okay, so here they've actually made it easy for us. So they're saying X to Y or Y to X. So unfortunately, my darlings, you won't be able to know this just by mere looking at it. You have to use your finger. So because we are using a generator, there are two R's there. So I'm going to use Fleming's right-hand rule. So I'm going to use my right hand. You must always make it like you're pointing a gun, like da 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 da. But this finger must move in that direction. This finger is your magnetic field. I'm going to place it in that direction. It moves from north to south. Think about your north magnet standing there, your south magnet moving there. It's moving in that direction. Looking at my diagram, it's telling me that it's moving anti-clockwise because there's an arrow moving in that direction. Remember, it moving clockwise. Clockwise and anti-clockwise is what we use to represent a time. So because it's moving in that direction, our watches also move in that direction, so it's moving clockwise. This is the force in which the armature will move. It's moving in this direction. But because this finger is facing moi, it means it's moving. If this is y at the top and this is x, so it means your current is going to move from the y to the x. Do not say top to bottom. The examiner will think you do not know how to read, you're not following instructions, and we do not want to go through negative marking. So let's do the first one here. So this is 10.1.1. So with 10.1.1, the current is moving y to x. Remember, you have to use Fleming's right-hand rule, so we can already see that the current is going to move in that direction. Remember, because it's alternating current, it's going to change as it moves along. So let's look at the next one. So it says here, on which principle or law is the working of a generator based? Now guys, this is very, very crucial and very important. And as you can think about it, in chemistry and physics, there's always a specific scientist that we always relate to in whatever topic that we're doing. For example, when we did momentum and when we did Newton's laws, it was all about Newton's first law, second law, and all that stuff. So whatever we were answering, we were always relating it back to him. So when we talk about electromagnetic induction, we talk about a guy called Faraday. And he was actually introduced to you guys in grade 11 when you did electromagnetism and all that stuff. So, and now remember, when we talk about a principle and when we talk about a law, it's things that do not change. It means if you go to any other country, it will always remain the same. So don't thumb suck, it's actually in your textbooks. So what principle or law is this generator working towards? And that is 10.1.2. And this is Faraday's law of electromagnetic induction. So you could have actually had it the other way around. You could have said electromagnetic induction by Faraday's law and so forth, but the examiner wants to see all those words. And as you can see in this question paper, it's actually only for 1 mark. So you don't get half a mark, unfortunately, in grade 12. So make sure that you have the whole word. The exam, you can't say Newton. Newton who? You have to say Newton's laws and stuff like that. So always make sure you have to go full on. So then we have the next one. It says, state the energy conversion. State the energy conversion that takes place while the generator is in operation. And this is for 2 marks. Now remember what I said. They can either ask you about a motor, they can ask you about a generator. The one is from mechanical energy to electrical energy. The other one is from electrical energy to mechanical energy. That's the different conversions that they're looking for. So don't use words like from power to working hard. No. Conversions of energy. So that is 10.1.3. So let's fill that one in. So if I have 10.1.3, the energy conversion, we know when we talk about generators, it's mechanical. You can actually even say kinetic energy, mechanical energy to electrical energy. Always think you have to put in some work to actually have the benefits. To electrical energy. So that's what this question was looking for. So already we actually are good to go. This is actually a very easy question, guys, or topic. So I would expect we get full marks for it. So now they've given us 10.2 and it says the voltage output. So they've already given us that output for an AC generator is shown below. How do I know this is AC? Remember, when you talk about alternating current, it will turn as it actually rotates. So, and it actually also makes a sine graph. So this is alternating, so I can see I've got an amplitude here with a height, that's the maximum points there, and the voltage is 340. So that's what I'm given. So now the nice thing, or the tricky, or not really the tricky part, but how the examiner makes it easy for you guys. If they give you a table, if they give you a graph or a diagram, it means all your answers must come from that diagram. Don't go and think and put things that are not there. Everything is coming from that diagram. I'm going to show you how. So the question that they're asking us now at 10.2.1, it says write down the maximum peak. Remember peak, like there's a song, the mountain peak, it means at the highest of that point. So when we're looking at this graph, the highest peak of this graph is 340, and you can see it's actually only for 1 mark. Voltage of the generator, that's the peak. That's all you need to do. That's the answer that we have. So this is 10.2.1. The peak of this generator is 340, but now remember you need an SI unit. It's a capital V, not a small v, because a small v means velocity. You also don't want to show the examiner that you are actually getting confused between voltage and velocity, right? Make sure that you use the correct SI unit. So that was very easy. So let's look at the next one. So now they're actually giving us a calculation. They're telling us that we have a stove, which actually makes sense because remember, when we don't have electricity, we use a generator, we can plug in our lights, a stove, a kettle, you want to iron your school shirt and stuff like that. You are actually able to use your generator for that. But then again, we can actually calculate different things that happen in that generator, whether it being the power, the current, the resistance, and so forth. So let's see what this question says. So here they're telling us we have a stove, which is connected to the generator above, meaning this one. And it delivers an average power, so they've given us power of 1,600 watts. Remember, it's also a capital W. And then 10.2.2 says we must calculate the RMS voltage. Now, my darlings, there's a difference between Vmax and the RMS, and this is for 3 marks. So let's see how we're going to tackle it. We have our power, we have our Vmax there because that is the peak, and they want us to calculate the RMS. Very easy. You just go to your formula sheet actually. So if this is 10.2.2, so I always write your formula. We're looking for VRMS, and I know that I can use the formula Vmax all over the square root of 2. Remember, this does not change. And now guys, what I always say, what I always teach my children, they've given you different formulas that you can use, but the safest thing is to always choose a formula where all the information that you need to plug in that formula is something that you're already given, which means you don't have to first work something out on the side and then bring it in and stuff like that, because just in case you actually got that wrong and then you might get everything else wrong. You might get marking for continuous assessment and marks, but we actually want full marks for this one because it's really simple. So let's see. I do have my Vmax. Where did I get my Vmax? I got it all the way on my graph, which was here, which was my 340. It's Vmax because it's the highest point of that amplitude. So here I'm going to say 340. I keep this under the square root of 2. Let's see what we're going to get. I do it exactly the same on my calculator, 340 over the square root of 2. And then I get 240 I'm going to round it off to 2 decimal places, which means the 6 will round off the 1 and make that a 2. Remember, from 5 going up, it'll then round it off. So I'm going to get 240,42. Remember, when we're talking about VRMS, we're talking about volts. So that is then again a capital V. So let's look at the next question. I think that's our last question. So the last question says we must calculate the resistance of the stove. So what do we have now? We have our Vmax, we have our power, we just calculated RMS. Now I'm looking for resistance. Taking it back from electricity, resistance is with an R. So I'm going to go to my formula sheet, find a formula that I can use, and I'm just going to plug everything in. So this is 10.2.3. So the formula that I'm going to use, I'm going to say PAVE. Remember, you must say PAVE because it is power, average. I'm going to say V squared RMS. This is the one that I chose. So there are actually a few that you could have done. Some of them are a bit of a long method around, but I'm just going to do one. So I've got my power. I did calculate my RMS, and I'm looking for my resistance. The power that I'm given for the stove that I'm plugging in is 1,600 watts. My VRMS is what I calculated, which was 240. We rounded that off to 2 decimal places, which was 42. And remember, my darlings, it's squared, so the whole answer is squared. All over, I'm looking for R. Now, I need to make R the subject of the formula. This is why you need mathematics to take physical sciences. I'm going to put this over a 1. I'm going to cross multiply. So 240.42 squared multiplied by 1 will give me 240.42 squared equals to 1,600 multiplied by r will give me 1,600 r. Now I need to make r the subject of the formula. I'm going to divide with what is bothering the r on both sides. Because I want r by itself, I must get rid of the 1,600. I'm going to divide both sides by that. 1,600 divided by 1,600 gives me 1. So I'm going to end up with r. Let me just summarize it out. I know it's only for 3 marks, but I would rather have you write out everything nicely so that the examiner knows what you're doing. So now I'm just going to put this exactly as it is in my calculator. And remember what I always say, always put brackets around it because otherwise it's going to do BODMAS. So I'm going to say 240.42, close my bracket, and that is squared, all over 1,600. And I get 36,13 because the 6 will change the 2 into a 3. Remember, if the number after the 2 is anything 5 and greater, then this number will change as we're rounding it off. So I'm going to get 36,13. And remember, when we talk about resistance, it also needs its own SI unit, which is a money key that looks like that, and that's what we call ohms.